Today's lesson is on calculating higher order derivatives. What this means is we've got first derivative, we could take a second derivative, which is the derivative of the derivative, third derivative, fourth derivative, and so on. So different notation. So two different notations when we're dealing with y. The simple one is just to say y prime, y double prime, triple prime. And then if we're going anything higher than that, instead of putting a million, we're going to, it'd be like y to the power, and then n in parentheses, the n representing like whatever derivative you're taking. Now, with y, usually we're dealing with dy dx. So first derivative we're familiar with, dy dx. When you take the second derivative, all of a sudden it's d squared y over dx squared. So the exponent on the d and the x. And then you can imagine the third derivative is just d cubed y over dx cubed. And then, similar to this one, we'll have dn to whatever power y over dxn. And I just realized this one, that was supposed to say f of x. So if we have f of x, this is just like that first example. We'll have f prime of x, f double prime, and then f in parentheses to whatever power to show whichever derivative we're taking. All right, so there is the notation, and now we can actually start taking higher order derivatives. All right, first example, f of x equals 2x to the 7th minus 3x to the 5th plus 2x squared plus 8. So we're going to take the first, second, and third derivative. So this one's kind of nice because it's just the power rule. So the first derivative is 14x to the 6th minus 15x to the 4th plus 4x. And then the second derivative is just take the derivative of the derivative. So 14 times 6 is 84, x to the 5th minus 60x to the 3rd plus 4. Let's go one more. Third derivative is the derivative of the second derivative. 84 times 5, so 420x to the 4th minus 180x squared. All right, next one, we're going to take the first and second derivative using implicit differentiation, which gets a little interesting. So I've got x squared y equals 5. So implicit equation and its product rule. So derivative of the first times the second plus the first times the derivative of the second. So derivative of the first is 2x times y. I don't add my dy dx because I didn't take the derivative of y, plus the first x squared times the derivative of the second, which is 1, and now I have my dy dx equals 0. All right, let's get dy dx by itself. So x squared dy dx equals negative 2xy. Divide by x squared. Dy dx equals negative 2xy over x squared, which equals negative 2y over x. All right, now we're going to take the second derivative. So, got, okay, so I still have an implicit equation, and now I have the quotient rule. Derivative of the first times the second minus the first times the derivative of the second all over the second squared. Okay, derivative of the first is -2 dy dx times x minus the first, which is -2y, times the derivative of the second, all over the second squared. Now this next part is interesting. Here I have, in this equation, this dy dx. Well, if you look up here, dy dx equals this. So now I'm substituting what the dy dx is in for dy dx. So I have -2x, just bringing those together, times dy dx, which is what I solved for, -2y over x. This I'm going to turn into plus 2y over x squared. And now I'm going to simplify. X's will cancel. I'll have positive 4y plus 2y over x squared, which is just 6y over x squared. So that is my final answer for the second derivative. Just remember that idea of when you find the first derivative and you're finding the second derivative, you have to substitute the first into the second and simplify. Okay, here's our last example. We're given this right here. We're given the first derivative is y to the third times cosine x, and we want to find the second derivative. And we're going to evaluate it at this point. So we only have to take one derivative because we are starting with a derivative, and we're taking the second derivative, so we're just taking the derivative of what we have. Okay, so implicit, and I have product rule. So the second derivative, derivative of the first is 3y squared times the second cosine x, add in my dy dx, plus, the first times the derivative of the second, which is negative sine x. Now remember, when we're taking the second derivative of implicit, we have the dy dx in. Well, we know what dy dx is. Dy dx is this, so we're going to substitute this in there. So 3y squared times cosine x times y to the third cosine x. I'm going to change this to minus, so minus y to the third sine x. All right, let's clean this up a little bit. I'm going to have 3y to the fifth cosine squared x minus y to the third times sine x. So now let's evaluate it. X is pi over 3, y is 1. Okay, so 3 times 1 to the fifth cosine squared of pi over 3 minus 1 to the third times sine of pi over 3. So I have 3 times, this would be 1/2 squared minus square root of 3 over 2. So then I have 3 times 1/4, so 3/4 minus square root of 3 over 2. I'm going to change that to 2 square root of 3 over 4 to get a common denominator. So 3 minus 2 square root of 3 over 4 is my final answer. And there is your full video on higher order derivatives. Derivatives of derivatives of derivatives. Good luck.